4 introductory problems today. Find the solution set, then graph on a number line. Same as the previous unit, but instead of one-step inequalities, we're on two-step inequalities. And it's not that scary. 2x plus 3 is greater than 15. So let's solve for x. Let's pretend this is an equation, and let's just do the same old two-step equation part. 2x plus 3 is greater than 15. We're going to subtract 3 from both sides, cancel out. If we subtract 3 from both sides, does that have any impact on the inequality symbol? No. So we've got 2x is still greater than 15 minus 3, which is 12. So now we've got 2x is greater than 12. And now to solve for x, I'm going to divide both sides of the inequality by 2. Because we divided both sides by positive 2, that inequality symbol is still true. X is greater than 6. But after I'm done with that, x is greater than 6 means legally, 0 in the middle, we're going to plug in anything with this endpoint, x equals 6, circle it. What values are greater than 6? To the right or to the left of 6? To the right. At the end of the number line, we put a big, humongous arrow. And is 6 itself invited to the birthday party? No, it is not. So that is the graph for how to do this. Number 2, 7x minus 9 is less than or equal to 26. Well, if this was an equation, we would solve it as such. We're going to add 9 to both sides. Cancels out. And now, does adding 9 on both sides have any impact on the inequality symbol? No. So now 7x is less than or equal to 26 plus 9, that'd be 35. So now we've got 7x is less than or equal to 35. If I divide both sides of the inequality, oops, messed up. 7x is less than or equal to 35. Means I'm going to divide both sides of the inequality by 7. And that means x is still less than or equal to 5 because I divided both sides by positive 7. Only dividing by a negative on both sides flips the inequality symbol. So that's my solution set. But now I need to graph this on a number line. So I'm going to put a horizontal Right? So I put a number line, 0 in the middle, 5 is to the right. I'm going to circle my endpoint, make it obvious. And all values less than 5 get shaded to the left. At the end of the number line, I put a big, fat arrow to say I'm going to negative infinity and beyond. Is 5 itself invited to the solution set birthday party? Yeah. So we shade in the endpoint. There we go. All right. Number 3, 2 more to go. 6x minus 2 is greater than or equal to 58. If this was an equation, I would add 2 on both sides. So I'm going to add 2. And greater than or equal to has no, it doesn't change because I added on both sides. No problem whatsoever. So 6x is greater than or equal to 60. And now to get x isolated, I'm going to divide both sides of the inequality by positive 6. No trouble whatsoever because x is now greater than or equal to 10. And now I've got 10 on the right side of the inequality. I'm going to circle it, and x is allowed to be any real number as long as it is greater than 10. Put a big fat arrow on the number line. And then I'm going to shade that endpoint because it's greater than or equal to positive 10. Last problem, and then we'll call it a day. 9x plus 20 is less than 92. If this was an equation, I would subtract 20 from both sides. Does subtraction have any does subtraction change the inequality symbol whatsoever? No. So that cancels out, and therefore 9x is still less than 92 minus 20. That would be 72. And now I've got 9x is less than 72. So now 9x is less than 72, which means I get to divide both sides of the inequality by 9. Because I divided both sides of the inequality by positive 9, this inequality symbol is still less than. So now I get x is less than 8. Now I've got 0 in the middle, 8 to the right. I care about this endpoint, and I shade all numbers less than 8. I put a big fat arrow at the end of the number line to say I'm going to negative infinity and beyond. Is x equals 8 invited to this solution set birthday party? No, x is less than 8, not less than or equal to 8. That's all the idea is. I just wanted to get your feet wet before we tackle some heavy-duty problems. Have a good day, guys.